Hey guys, welcome to my channel. My name is Lukesh. So today we'll be going through one of the videos that is available on YouTube on PySpark. Although it's a 4-hour long video, but we'll be going through a snippet of this video. And if you're working with Spark in whatever capacity there it is, maybe you're working as a data architect, maybe you're working as a senior data engineer or a data engineer for that matter, I would strongly recommend that you go through this video. This video is presented by one of the founders or the first team that worked on Spark, or the founders of the Spark. I think that would be the right terminology. And they have tried to cover the in-depth knowledge of what Spark is, how Spark internal works. I'm not able to recall the name of the presenter, but I would definitely going to put the link of the video in the description box below, so you can check that out. So it's always good to revisit the technology, the basics of the technologies that you're working on, because these are like the building blocks, and this will help you understand, maybe resolve the production issues. Otherwise, mostly you will be relying on online help, or you might be um, uh, paying or doing a guesswork, which might not be ideal if you are an expert, or you if you want to be an expert in certain field. So with that said, let's look into this video. So this would be a first of its kind where we would go through the video, and I'll be doing a commentary as we go through the video, not necessarily after each sentence, but maybe after 2 or 3 minutes. So you might have seen some review videos, so you can treat this video similar to that. But here we would be learning, we will be studying rather than reviewing some movie or some sort of series. So let's see how it goes. And with that said, let's now move on to the screen. So this is the video, guys, that I was talking about, and the title of the video is Advanced PySpark Training. It was conducted by Sameer Faruqi from Databricks. So apologies that I don't remember the name, or I was not able to recall the name in my intro video. So let's pick it up from here. So as you can see, out of nearly 6 hours of the content, I've already gone through 3 hours. So I would strongly recommend, again, I can't recommend enough that you should go through this video. And it's not that you should try to finish it in one sitting. This might take weeks, months, but that's okay. If you're starting out, you want to be absolutely clear on the Spark concepts. If you already know Spark, then this would help you in brushing up the Spark concepts, or get deeper understanding on how Spark works. So we'll pick it up from here. So I'm not sure which topic is being discussed, but let me just hit play.
Find the last time the shuffle happened and just keep redoing that. If that's not clear, well, after 5 o'clock, I will, like I said, hang around for a while. Now, one thing, if you're using PySpark, then the stored partitions will always be serialized in memory with the pickle library. So it doesn't matter if you choose a memory serialization level that's on or off, it will always do this. Okay. So here is actually an interesting slide. Here we go. Sorry, I just had to fix something. So in the executor JVM, this is how the default memory allocation works. By default, 60% of the JVM is going to be used for caching. The JVM memory will be used for caching RDDs. The 20% of it will be for shuffle memory, for the map side and reduce side aggregation, and 20%, the rest basically, the remainder will be used for the user programs, which are your threads. So if you are seeing executor JVMs crash with out-of-memory errors, which would be logged by like the Linux kernel saying like it had to terminate a JVM for misbehaving and trying to use up more memory than you had told it could use, then you need to figure out which one of these three things caused that. It's probably going to be user programs or shuffle memory most likely. So with user programs, maybe what you want to do is increase it from 20% to like 40% if your threads are making that happen. And by the way you do that is you just have to you can't set the user program memory level. You have to just starve out. You have to reduce the Spark storage memory fraction and the Spark shuffle memory fraction. Or if you see that every time a shuffle happens, that's when the out of memory issue is happening, then consider increasing the shuffle memory side. This is what those three things actually are in detail. Um, what's that? The shuffle memory is set by that setting, Spark shuffle memory fraction. It's one of the settings in Spark.
The link that we have, probably the older one, it says fix.
It just says fix that. That's what I was fixing when I hid the slides from you. I forgot to do that last night.
Okay, so
Yeah.
it's not available right now.
This is the only fix I've made so far in the deck.
Okay.
Yeah.
To be very clear, if you don't cache any RDBs at all, 60% of the memory.
It's too much. Reduce it.
Never used.
It's never used. If you're not caching it, well, if you're not caching anything at all, I'm not sure, even if it's materializing RDDs for a fraction of time and it's pipelining stuff, it might still use that part. I wouldn't starve it out completely, but if you're not going to be doing much caching, then reduce it significantly, probably to reduce it down to probably 10, 20% if you don't care about caching RDDs at all. But you probably should cache RDDs. What's that? No, if you have Tachyon and you're definitely going to be using Tachyon, then you can probably, lower that 60% to something much less. But I don't think you should go to 0. That might cause problems. I haven't tested it like that. If the shuffle memory is sufficient, then yeah, the map side will eventually go to disk anyway, but on the reduced aggregation side, it will just keep it all in memory, and that'll make your shuffle much faster, actually, if you can fit the reduced aggregation.
So let's look into this. So I think we have started with, in this particular snippet, we have started with talking about, or in fact, Samir has started, discussing about the memory distribution on each executor. Now, this could also be true for a driver, and this is especially important if we are getting out of memory errors. And remember, guys, this video was made in 2014, which means most of the properties had to be configured. It doesn't mean that those properties, whatever that came out of the box, were, the best properties or the best configurations, if it makes sense. But you had to change it or tweak it based on your workloads. So let's first of all think that if this memory distribution is true with Databricks PySpark, especially if you're using Azure, you would be using Databricks PySpark. So most of the properties come out of the box, and now they have done a good job. Spark and Databricks, they have done a good job in making sure that these properties have not to be fiddled with or doesn't require any change. So for that purpose, let's try to see what is the memory distribution of an executor. So we will just do a random search on this. Memory distribution of executor, or for that matter driver, and Databricks PySpark. Oh God, I am using Yahoo. So let me just tweak it a bit. I don't know why it happens every time I restart my laptop, and whenever I try to search anything, it picks up Yahoo as the default search engine. Maybe I need to change in the settings, go into the settings, and default browser, default. I remember there was a place where I could, change this to Google, but since I'm making this video, I'm not able to recall that. Maybe yeah, search engine, so you have to change it to Google. Okay, let's again just copy this entire thing, whatever question that we wanted to ask, and put it into the thing in the search box. So let's see, what do we get here? So I think this might be a issue that somebody might have raised it. Okay, maybe this might be the link where it explains the things. Let's do one thing. We'll rely on Perplexity, website to find the answers. If you've not used Perplexity .ai, I would recommend you do that, because this is the route most of the search engines or the search engine companies are taking. So they're not only going to provide you the link, but they are going to give you a good summary of the answer that they think is the right answer. So we got something. This is a YouTube video. Let's see what it says. Assembly memory between the is crucial for optimizing. That's okay. Driver memory as an architecture. It is for creating okay. Executor are the worker nodes that perform the actual data processing, storing cache data, holding intermediate results, and then executing tasks, which is accurate as per this. So you have some cached results, and then you have user program and shuffle memory. But we want to know the percentages if we can get that. Just bear with me, I think we should be able to find the answer. So by default, the amount of memory available for it is located within the Java virtual machine. This is controlled by spark.executor.memory. So you have three components: execution memory, storage memory, and reserved memory. Some unexpected behavior observed in a large amount of memory for energy means whole heap memory. Okay. That's okay. Maybe I think we can go with this distribution in executor JVM. Maybe instead of driver or giving it a prompt of driver or executor, we should just say executor JVM database PySpark. Let's see what it comes up with. So you have to understand that memory allocation is a complicated topic, it's an advanced topic. So we might not be able to. You would need a really deep dive into the Spark internals to understand it. Total executor memory is Spark executor memory plus Spark. OV memory management, dynamic memory management. That's okay. Maybe for now we can go with these settings. So let's
Aggregation side, all in
understand
memory.
more. Yeah, and one of the other things that you might have encountered, especially if you're working with production workloads, is that you might be getting a driver out of the memory issues. That is because if you're trying to return a huge amount of data to your driver, that could be a result of a lot of shuffles. Uh, so in that case, you might want to increase the driver's memory. Usually, I've seen that it could be 1 GB or 2 GB, but maybe you want to increase it to 4 GB or 8 GB. That you can do that, and there is a specific property related to that. You could either use Spark UI to do it, or you could use the code to do that. And one of the things that Samir started this video, at least for us, was talking about serialization and deserialization. So serialization, I think it's a process of converting the data that we have into a binary format so that it is easily understandable by the computers for interpretation. And similarly, if it is a deserialization, it means converting the binary data back to the data which could be presented to the users or which gets saved in the databases. So it's very important to understand that, because if you are saving your data in a serialized format, there might be a little lag when you try to deserialize it, because first it has to convert it into deserialized format. So this specifically comes in handy if you are using persist. Remember, there are two commands that we mostly use, cache and persist, for saving the data in RAM so that that data could be easily accessible. So let's now move forward.
If it doesn't fit, it will still spill gracefully. And it won't, the shuffle thing should not cause an out of memory condition actually, but it could happen in extreme cases. If you want to understand the memory consumption of an RDD, you can look at the UI like I showed you, or you can actually look at the logs for.
And another thing that we have to talk about is that if you are trying to cache the data and the data volume is high, then what would happen is, obviously, if it's a CSV file, if it's a data frame, you will have partitions in that data frame. So some of the partitions would be saved in RAM or memory, and some of the partition would have to be pushed towards the disk. Disk is here nothing but the place from where you're reading the data. For example, if you're reading a data from ADLS Gen 2, then those partitions would reside in your ADLS Gen 2 location rather than the executor memory.
For the, I believe it's the, look at the Spark context logs on the driver program, and you'll see stuff like this. This is showing that this means that partition 1 of RDD0 consumed 717 kilobytes of memory. Okay, this is a very fast section. I'm going to fly through this section. I just want to point one important thing out. Two or three things actually, but really quickly. Serialization is used for all these things. So when you change the Spark serializer, it's going to affect transferring data over the network, spilling RDDs down to disk, caching into memory serialized, so I should say persisting to memory serialized, because the word cache has a very specific meaning, and broadcast variables will use it as well. So just the short of it, I don't want to spend too much time here, is in general, if you just do nothing with serialization, so if you don't set it, it will use Java serialization, which is slow. It's flexible because it works on pretty much all data types, but it will be slow, significantly so. So it's highly recommended for production applications to switch to the cryo serialization. And this is like super well documented in the Spark docs. So I'll refer you to that. But this is how you can set it on a Spark context when you make your configuration object. Here I'm setting it to the cryo serializer. Um, let's see. And the reason Spark doesn't do cryo automatically is because certain custom classes that you have that you're instantiating objects from will not automatically just work with cryo. So you're going to have to register your classes with cryo, and you'll have to maybe mess with like this buffer configuration as well. So I just want to point out that you should use cryo for production if you want to speed up your application, but I'll refer you to, once again, to the documentation and go deep into how to actually set this up. Okay, so high churn is when you are just maybe caching without a care. You're just caching every RDD. So it's churning a bunch of objects within your JVM heap, and it's going to eventually keep triggering garbage collection.
Yeah, so I think what we saw in the last couple of minutes was mostly, Samir talking about the serialization. So in general, I think whatever I explained, serialization, if you want to, just remember that serialization is limited up to that. But if you want to, get into deeper understanding of how serialization works, maybe you can look up on that. Just, circling back to what I said about spilling to disk. Uh, so I think disk here could also refer to the local, directory of the executors. So which I think we would try to understand more in the coming videos or as part of this video, and I'll make a note of it as well. So disk here not only refers to the primary location from where you are reading the data, but it also might refer to the place or to the local directory space in the executor. So let me just make note disk local directory or the primary directory. So yeah, so this is important. So I think for our first video, this should be enough. I don't want to make it a longer video, although in coming days sessions we might want to do that. But now I think for now we should stop here, and we'll meet in the next video. Till then, take good care of yourself and don't forget to subscribe this channel. Just try to share it with as many people and folks as possible. Let's try to grow this. Let's try to learn together. And Happy New Year, guys.